Hello everyone and welcome to another Minitab edition of Fun Times in Statistics. As you'll notice, we're using Minitab Express today. We're going to be focusing on doing some descriptive statistics to our quantitative data you see here on the right. On the left, you'll notice I have the notes from the first part of this Minitab video. I did split it into two parts because I want to use two different types and two different sets of data to show you some different things. And to just, do some different stuff this week rather than having a long video. I split it in two parts. Hopefully that helps you as well as far as attention span goes. So the data I have today is actually not real data. I had to do some randomly generated numbers to create this, but it's just to help you see some patterns and to look at how different distributions look. And the data in the second video will actually be real stuff. So let's get this party started. So this data as well as this document appear above this video on Blackboard, and we're going to start it off by just calculating ourselves a quick mean and standard deviation on the uniform variable. So how you do that in Minitab Express is there are two ways to do so. You can go up here in the top menu if you have one on your Mac to the statistics button, and then choose summary statistics and then descriptive statistics. I know, lots of statistics today. And you'll see the following menu. Now again, we notice that Minitab likes to mark when it has a continuous or a quantitative variable with this little smooth graph symbol, which is how we usually draw them as well, as you saw in the notes. So I'm going to throw the uniform variable in there since that's the one I'm going to be dealing with in this example. I'm not going to be grouping anything in this video. I will be in the second one if you're wondering what that's going to be used for. And then I'm going to go over to the Statistics tab. So when I click on that, it's set to do the default items here. So I'm going to uncheck a bunch of stuff. I'm going to be using some of these later. But there's a lot of things on here. Notice the range is here. There's the variance. I got standard deviation. There's standard error, which is something we talk about later in the class. There's the mean. And it's important to know, oh, look, there's the mode. Woohoo! That when it comes to what we're looking at with descriptive statistics on Minitab is it's always doing statistics, not parameters. So it's always doing the sample version, not the population version. So that should be something that you're aware of when you're doing your calculations. So there's my mean and my standard deviation for this variable. Next up, I'm going to create a 5-number summary of the symmetric data so we can see the look at how you can do that. Now for this one, I'm going to show you a slightly different way to get the information on Minitab Express. So this is going to be the same as going to statistics, descriptive statistics, like I did in the top menu. If you don't have that option, you can go to summary and you'll see this option that says descriptive statistics. And then I can throw the symmetric variable in there since that's the one I want this time. So this is a little bit faster because you only have to click basically one button and it shows up. And then I hit the statistics tab and I'm just going to uncheck the stuff I don't need. And this is one thing that's a little bit of a downside to using Minitab to do this is that when it comes to doing the 5-number summary, which you should know from the notes, is the minimum, the first quartile, the medium, the third quartile, and the maximum. Minitab doesn't know that, but it knows that you might want some of these, so they're all right close together with each other, but at the same time, like, you can't click one button just to get the 5-number summary, which is unfortunate. Let's go ahead and hit OK. And so here's the 5-number summary for the symmetric variable. Fun times. So what I'm going to do next is, although we did histograms last week, I'm going to make a histogram of the uniform variable because I want you to see what it looks like and why this mean and the standard deviation makes sense for it. So I'm going to go up to graphs. I'm going to select histogram. I'm just going to do a simple one this time because I'm just dealing with one piece of data. Let's throw uniform in there and hit OK. I know I did that kind of fast, but this should be a little bit of review at this point. And this we consider to be uniform, which means just one value or everything about the same, because most of my bars are about the same height. Now this uniform data does have some noticeable dips at the end, so it almost has this kind of curve feel to it, with some rather severe modes occurring in a couple different places. So it's interesting how bumpy this one is to me. But it looks like the center of the data is just shy of 50, so that value reported from actually calculating the descriptive statistics makes sense to me. I would guess that it balances probably right about here, around 50 to 51, which is exactly what we saw back here. So it appears that, it looks like what we expected. Now, as for the spread, it was about 14. So most of your data should be within 14 of 51. And if you go about 10 out, 14 out, you hit about 64, which is pretty much everybody that way. And you go 14 down and it's about here. Yeah, that seems reasonable. Now, when I say most, I really mean when we're looking at things that are relatively bell-shaped. Unfortunately, this is not. It's uniform, so it's not quite what we wanted. So what I'm going to do next is I'm going to do a graph of the left skewed, the right skewed, and the symmetric, so you can get a little bit of an image that looks like the notes from what we had last time. And I'm going to do a histogram of all of those guys with the same scale as one visual element. And then I'm also going to do some summaries of that so that I can see just how they look when you compare them to each other. I am going to have to pause this because I'm picking up another sound. Sorry about that pause. We had some alarms going off in my house because I am an idiot and forgot to change the batteries in my fire detector, smoke detector. Anyway, so we're going to create a display that shows the three of these together so you can get a look at their shape, and keep that in mind when we go to the next part in number 6. So I'm going to go to histogram. I'm going to choose multiple y variables because I do have multiple y's that are unrelated, and then I'm just going to throw all these in here by double clicking. And when I hit OK, we'll get a bunch of graphs. Now these are all displayed together, which is nice, and they're on the same scale, which is what Express defaults to. That makes it easy to compare them. So you can see their shapes are what you expect. Clearly the skew left distribution has this outlier out here just chilling and doing his own thing way out here to the left. And my symmetric looks like how you would expect. Keep in mind when you see the word symmetric, real data is very rarely perfectly symmetric looking. It's going to be, relatively the same on both sides, but it's not going to look perfect. So if you're looking over here and thinking that this little lump here matters, it doesn't. It's just close to symmetric, close enough to where this actually looks really good for something I randomly generated. And the same thing with this right skew guy. So if you were looking at these, what you should do at this point is kind of guesstimate where you think the mean and median are going to be. So for the symmetric one, it's fairly easy. Let me make this a little bit bigger if it'll let me. I'm going to get rid of my navigation view to do that. Sorry. Oh, that really didn't help. I just want a bigger picture. Oh well. Anyway, so it looks like it's about at 50. One thing to keep in mind with the mean and the median, when it comes to symmetric data, they're going to be about the same, so it doesn't matter which one you would use. And then when we go over to skewed left, I would probably guess the median is going to be probably about right here, so just below 50, maybe around 48, 46, maybe even lower than that, like 44 for the mean, because it's going to be, sorry, I was talking about the median first, because it looks like area-wise it probably is about here, because remember this height means something. So if you imagine these as like Lego bricks and you're stacking them on top of each other, like I want to use the same number of Lego bricks on one side as the other when it comes to doing the median. And then the mean is probably going to be a little bit lower than that because it's going to be pulled by this extreme outlier. Now the right guy does not have an extreme outlier compared to looking at the left skewed one. So I'm willing to bet that this one's mean and median are just going to be slightly different and not all that far off from each other. So I'm going to guess it's probably going to be like, I don't know, around 52-ish for the median, I would say. And then my mean is probably just going to be a little bit larger than that. And I'm a very observant person today. I was going to say an idiot, but one other thing I forgot that Express does, it always gives you the summary statistics for this, and it picks what it does for this as well, so keep that in mind. It gives you the means right here. So you notice they do all have different means, and they're all slightly different from each other, and their standard deviations are also slightly different from each other. But what I'm going to do now is I want to go ahead and do the 5-number summary for the symmetric so you can see that they are very close to the same. And then we're going to do some box plots. And I'm probably going to do multiple box plots with the next one. So if you're wondering why I'm only going to do one, we're going to do more in the second video. So like I said, I tried to divide this up a little bit for you. So now I'm going to go to summary. Come on. I don't know why she's being slow today. Descriptive statistics. So I want to do the symmetric one. Did I already do the fun? I already did the 5-number for summary for this metric. I wanted to do a skew here so you could see that yes, it turns out the mean is slightly different. So I think I want to do the left skew because it's more extreme looking. Let me go over to statistics, and I just am going to grab the 5-number summary for this one because I want to compare these two. I'm going to hit OK, and I'm going to copy this over to my document because I want to compare it to the previous results, and that'll be easier to do. Boop. Nope, I hit the wrong button. Sorry. If I have them side by side. So I'm just going to hit enter here like a couple times so I can bring this up on the screen a little bit. So there's my 5-number summary with my median for my skewed left distribution. And now I need my navigator back. Awesome. It seems like I've done this, and I practiced this video once before and I still am doing crazy stuff. So like I said, the skewed left, it's going to have a mean that's going to be lower than the median because these extreme outliers are going to pull it away, especially that one, and pull it down and make it seem smaller. So if you look at the median for this one, it's about 47, which I guessed it around 48, so I wasn't too far off. Yay, observations. And then you look at the mean and you're like, oh, well, it's 44. Yeah, it is lower because it's being pulled by that outlier. I know that it's very tempting when things are this close to each other to say things like, well, that's not that big of a difference. But be careful, scale on one thing is, scale based on one measurement is not enough for you to tell how far or how close things are. That's why we needed z-scores. By just looking at the mean and a simple single value, that's not enough to say are they close together or not. We need distance for that. Our distances or our measures of variation are things like standard deviation. So being 4 off when something is on the scale of around 15 as its average distance, that's a third of the way away from each other. That's kind of far. It's not nothing to laugh at. I actually am going to run the 5-number summary for some of these other ones too, so that you can see what's happening there. So I want to do skewed right and the same thing. Unclick all these and copy it over. It's not going to say that this is the skewed right one though. That's what I'll do. I'll grab this and paste it up above. Now I'm just changing my mind on what I'm going to do because I'm having a good time. Doing some statistics. All right. So the skewed right was the one that had a little bit less skew to it. So if you look at its median, it's 52, which is slightly smaller than the mean. So there's some evidence of some skew. And then I'm going to run the descriptive statistics again. So I'm just going to hit make similar and throw a symmetric in there. And even though I already did this earlier, I just want it again. So 49, pretty close to 50. So notice how much closer with the symmetric the mean and the median are than they are with the left and the right. So a good indicator that you're going to end up with something that's symmetric is they should be 1 unit or less away from each other. And I would prefer they be almost perfectly the same before I would call they're symmetric. And if you're not sure, remember, you can always just make a graph of the distribution rather than trying to guess from looking at the values. Yep. All right, last but not leastly, let's create ourselves a box plot. So unsurprisingly, a box plot is located in graph. There are 2 ways to get to graph. You can press the graph button here on the ribbon menu right there, or you can hit graphs up here along the top menu. So I'm going to choose graphs. I always forget it's plural, and then choose box plot. Since I'm doing just one simple variable right now and I'm not doing any groups or multiples yet, I'm just going to select simple, although I think I'm going to mess with this already and show you a multiple. And then I'm going to hit, oh, I don't want to do uniform, I want to do symmetric. And then I'm going to hit OK. Alrighty, so there is our symmetric box plot. So it always drives me crazy doing vertical box plots. I kind of hate them. I think I want to switch this up and change its orientation. I like it better when they're across because I feel like one variable you're used to the x-axis, like the number line, it should be going across. And this looks like what I expected. So when I see symmetric, I think it needs to be the same on one side as the other, which looks good here. The width of my lower box, my lower quartile, and my upper quartile are about the same. So my distance from my medium to Q1 and my median to Q3 looks to be about the same. My whiskers, so this minimum out to this Q1 and this Q3 out to this maximum, look to be about the same length. So I'm saying this line is about the same length as that line. I usually ignore the outliers when I'm trying to describe shape because, again, they're extreme values in your data set. They actually might not even belong. They might be a mistake. So I tend to ignore them when I'm describing shape. They're not still a part of the shape, but when you're describing overall symmetry or skewness, you shouldn't. Okay, I'm going to do one last thing with this. So I'm going to do something that's not on the numbers. I hope that's okay. I'm going to go to Graph, Box Plot, and I'm going to do a simple with multiple Y's. This means that I have data in separate columns. I'm not grouping it in any way, shape, or form. So I want to be able to compare these guys. So I'm going to throw everybody in here so you can get a look at what this is going to look like and how skew looks for something that is a box plot. And once again, I'm going to change the orientation because I think vertical is actually kind of hard to read with this. There we go. So, can I make this bigger? I'm going to copy it over and then make it bigger on my Word document so I can zoom this in and talk about this a little clearer. I hope you enjoy that because I feel like it's a little bit better of a discussion when it comes to comparing them. So when it comes to comparing box plots, the first thing I look for is, do their medians look about the same? And these are fairly close, like on average or for their typical values, they seem pretty much the same. So I go looking for sameness first. Now, nothing else here looks the same to me. So I looked at their centers, they look about the same. Next up, I'm going to say what looks different. Well, I go usually to spread. So I go for shape, center, and spread, looking at those three. So when it comes to their spread, I'm going to use interquartile range because it's the easiest to see. So that's the distance between Q3 and Q1. I just did that backwards, Q1 and Q3. So it's the width of this box, and this one has the widest box, which is interesting because that means uniform has the greatest amount of variation or spread here. And then the spread of the skewed left and skewed right are almost the same, with the symmetric being pretty close to the two, but being the one that's the smallest, which makes sense because when you looked at the symmetric graph, it looked like everything was pretty tight and close together. So not having a whole lot of variation or spread is not a huge shocker. Okay, the other thing is that the symmetric and the uniform are the ones that have symmetric shape. The left side looks almost identical to the right side of the graph. Yeah, plus or minus just a little bit. Now, when you look at skewed left and skewed right, notice that one side looks a lot longer than the other. Notice it's the right side that looks a lot longer on the skewed right, and the left side that looks a lot longer on the skewed left. This is the other reason to put it down and make it horizontal instead of vertical, because then its skewness matches the direction that the longer side goes. Faces? There's the word I wanted. And notice that with skew, you tend to have outliers on the tail ends and not so much on both sides. You can still have them happen on both sides, but it's kind of rare, to be honest. And then the uniform distribution, since everything's so close in value to each other, nothing is going to be an outlier, which is interesting. Now, the last thing I wanted to show you, you can see by actually clicking on the graph. And I don't want to do this on Word because you can't see it on Word. So if you go in here, you can actually click on your outliers and see what they actually are, which is nice. Oh, look, it's an outlier. It even labels it as such. And it tells you what row it came from. So if you wanted to get rid of that row because you didn't feel like it belonged, you totally could. And also, if you just leave your mouse hovering over any of the boxes, it'll give you some summary statistics of what's there. So if you're working on a problem and you notice you need both the median and the IQR, and you needed a box plot, just make the box plot, leave your mouse on top, and you immediately get the results you need. Or use the summary statistics below, because that's a little bit faster. Alright, so that's the extra things I added that I didn't need to, or that I didn't plan to in this video, but I hope it's been helpful. And that's all I got. See you in part 2.